All right, so yesterday we were covering even and odd degrees. Now we're going to be covering even and odd functions, okay? So this is different than degrees. Okay, so here we have a parabola. A function is an even function if the graph is symmetric with respect to the y-axis. So if you can take the y-axis and cut the graph into two equal parts, this is considered an even function. Okay, so if we get the points here, -3 goes with 1, 2, 3, 4. -3 goes with 4. -1 goes with -3. 1 goes with -3. And then 3 goes with 4. Okay, so if you notice, this is where it cuts into half, and these numbers, you can show the symmetry based off of here. Okay, now a function is odd if its graph is symmetric with respect to the origin. So if it is symmetric with respect to the origin, so here is an example. Now, when we do symmetry across the origin, not only do you have to reflect across the x-axis, I'm going to take this point and reflect it across the x, but you reflect it across the y and you land back onto the same point. Okay, so you have two reflections on here. Two reflections that you need to make. Okay, across the x and the y. Okay, so for example here, we have this point where reflected across the x-axis, it ends up down here, and then you reflect it across the y-axis, and you land right back onto this section of the graph. So when you have your points, you have -6 goes with 1, 2, 3, 4, 5, 6, 7, 8, -8. And then -3 goes with -1, 3 goes with 1, and 6 goes with 8. So if you notice, just like we had on the other problem, you can see the symmetry here. But not only is it symmetric, but the signs change. So that's a way that you can be able to tell off the points. So a function does not have to be even or odd, okay? If the graph of a function does not show symmetry about the y-axis or about the origin, then it's neither even or odd. So it doesn't have to be one or the other, it could be neither also. So if you notice here, if I cut this in half, you can tell that the y-axis doesn't cut it in half. And then also if I reflect this across the x and then across the y, I don't land back on the graph. So this has neither, okay? Neither. The same thing here, the y-axis does not cut this into two equal parts. And then if you try to reflect, say this point across the x, and then across the y, it ends up out there. So this is neither also. And then neither. And then this one, the same thing, you can't cut the function into two equal parts. And if you try to reflect, say this point where we reflect it across the x and then across the y, we don't land back on the graph. So this is also neither. This is neither either even and or odd. Okay, so here it says determine whether the degree of the function is even or odd. And whether the function itself is even or odd. So remember, the degree and the function is two different things. So the way that we can tell if the function's degree is even or odd is we look at the arrows at the end behavior, and you see that they're both pointing up. So this is an even degree function. Then the next thing that you check for is, can I cut this into two equal parts with the y-axis? And you can tell that we can cut it into two equal parts and is an even function. So it is an even function. It's okay, so let's look at the next one. So this one, if we look for the degree, if we notice the end behavior, it is pointing up and then it is pointing down. So this is an odd degree. Okay, now we're going to check to see, is this an odd function? So when we're checking the odd function, we're checking for reflection. So I'm going to take this point up here and I'm going to reflect it across the x and then across the y, and I land back on the graph. So because that happens, this is an odd function. Okay, and then the last one here, this one, if we look at the end behavior, it is pointing down and then it is pointing up. So they're pointing in opposite direction. So f of x has an odd degree. Okay, now we're going to check to see. We can cut it into two equal parts with the x-axis, and if we reflect, say we take this point and reflect it across the x, and and then across the y, we end up over there, and we don't land back on the graph, so and is not an odd function, okay, because it doesn't have that origin symmetry. Okay, so we're going to try a few more. So f of x has so we're going to check to see. Based off of the end behavior, this is pointing up, this is pointing down, they're pointing in opposite direction, so this is an odd degree. Now we're going to check, is this an odd function? So we take one of the points and we reflect it across the x-axis and then across the y-axis. And if we land back on the graph, then it is an odd function, but it does not land back on the graph, so this is not an odd function. Okay, let's try the next one. This one, the end behavior is pointing up, up. So this makes it an even degree. Okay, but we're going to check to see, does the y-axis cut this in half? And it does not cut it in half, so it is not uneven function, sorry. It is not an even function. So just because it's an even degree doesn't mean it's an even function. Okay, and then the last one, if we check out the end behavior, this one is pointing down, down. So this is even because they're both pointing in the same direction. It's an even degree. And can we cut this in half with the y-axis? And you can see that it cuts it into 2 equal parts. So this is an even function. So remember, even degree and even function are 2 different things. All right, now the last part. We can determine algebraically if a function is even or odd or neither by plugging in a negative for your function. So if you plug in a negative x instead of x, and you end up with the exact same function, then this is considered an even function. If you plug in a negative for the x and your whole function changes signs, then this is considered an odd. Now remember, it can be neither. It can be an even function, an odd function, or neither. Okay, so when we're checking for the even, all signs stay the same. Stay the same. For an odd function, all the signs are going to change. All signs change. Not just one, not just two, all of them have to change. All signs change. So let's go ahead and try some examples. So here we have f of x equals x squared minus 4. So we're going to plug in a negative for the x. So we have f of negative x. So everywhere when we see an x, we're going to plug in a negative. And then we simplify. So whenever you square a negative times a negative gives you a positive. So this ends up changing to x squared minus 4. All right, so we go ahead and take a look. Did we stay with the exact same function? X squared minus 4 and x squared minus 4. We did, so this is an even function. Okay, so let's go ahead and try the next one. We're going to plug in a negative instead of the x equals. So everywhere where we see an x, we are going to plug in a negative x. So this one we had double minuses because this is a negative here. And then we also put, instead of x, we put a negative x. Okay? So negative x to the third power, a negative times another negative is going to give us a negative, x cubed. And then a negative and a negative makes a plus, so plus x. Okay, so if we check, this one was originally positive and it turned into a negative. This one was originally negative and it turned into a positive. So all the signs changed. Because all the signs changed, this is an odd function. And the last one. Okay, we're going to go ahead and take f of x and plug in a negative instead of the x. And then what we're going to do next is simplify. So here we have negative 3x squared, oh, not negative 3x squared, negative x squared is going to give us a positive. So it'll end up being positive 3x squared. And negative 2x times a negative x gives us a positive 2x. Okay, so then we go ahead and check the signs. So 3x squared and 3x squared, this one stayed the same. 2x and negative 2x, this one changed, okay? So either they all stayed the same or they all changed. So that means this is not an even function or an odd function. This one is even. Okay, so just remember for this section, you just need to ask yourself, did all the signs change? Okay, then it's odd. Did all the signs stay the same? Then it's even. And if some of them changed and some of them didn't, then it is neither. Okay, thank you guys.